Hi everybody, my name is Hao Li. I'm the CEO and co-founder of Pinscreen, and today I'd like to talk about virtual connectivity and avatars in a post-pandemic world. So these are all images that we're all familiar with these days. People wearing face masks, we're not seeing each other, and we have to enforce physical distancing when we do grocery shopping, for example. And the pandemic is not just impacting our daily lives; entire life events industries are being shut down. There are no more music concerts, sports events, no more conferences, and businesses are forced to actually go entirely online, right? So they have to close a lot of physical stores. And one of the recent surveys are showing that 85% of all the customer interactions have to be handled without human agents by 2021. Another thing that I'm guessing a lot of you are familiar with is this stressful situation where we have to all work from home, self-isolation, and the only way to really interact with each other, with our colleagues, with our friends, is really through video conferencing these days. And that's not really how we think the future is going to be, especially if we think about how communication has to be and have a better way to replace physical interactions. So here are a couple of interesting technological trends that are sort of showcasing how we can move toward that direction. So here's an interesting work from Facebook Reality Labs, where they're using virtual reality as a platform to enable virtual interactions in the virtual space using realistic avatars, right? And this kind of technology really showcases how we might interact with each other in the future across boundaries and not be in the same physical space. But the main issue here is that this is still a technology that will still take a couple of years to be accessible by consumers, especially because there is a need here to capture the subject using a studio-like capture setting, right? So you still need to record a lot of performance of the subject in order to build the model. Here's another example from spatial.io in an augmented reality setting where they're using slightly more accessible avatars to reenact themselves, and to enable telepresence. So here they're really showcasing how you can use voice to have lip animations, how you can have use your controllers to have some hand gestures in order to enable collaboration and interact and social interactions in this augmented reality setting. And how are we going to interact with e-commerce platforms in the future? Right now, we have websites, we have chatbots, but I really think that someday we're going to replace them all with human-like virtual assistants, where people can have a more natural and more personal way to interact with e-commerce websites. Here's a great example on how musicians are leveraging game platforms to throw virtual live concerts. This is a great example from Epic Games. They're basically recreating a virtual version of Travis Scott, who is performing inside Fortnite. And this is a great example where it actually goes beyond just replacing a physical concert, but they have the ability to reach out to tens of millions of viewers in real time. And we also have entirely synthetic humans that are becoming virtual celebrities or virtual influencers on social media platforms such as Lil Miquela. One thing you can see here is that there's this trend of digitizing ourselves and the ability to actually create virtual humans. And one of the issues here is the production effort to create virtual humans, right? So traditionally, we're seeing that you're using a standard computer graphics pipeline that is used in VFX or in the gaming industry, and those are very requires a lot of efforts from digital artists and are very, very costly. So the turnaround time is very slow. It's not something that is at the point where it's entirely consumer accessible, especially when you're talking about photorealistic content that you want to generate. So again, right, so CG humans is a hard problem. There are these well-known problems such as the uncanny valley effect. And some of the best examples we've seen so far are in the VFX industry, where you have really, really convincing, lifelike digital humans that are reenacted inside, big production movies. The only problem is that they do cost millions of dollars and months to just create a couple of minutes. So fortunately, there's also a lot of progress in the real-time graphics space. This is an example from Digital Domain, where they're showcasing this end-to-end approach of capturing the performance of an actor and mapping this in real time onto a digital version of himself. And this the results are very convincing. The only thing is that the performer still has to wear this, very complex mocap suits, which requires calibration, and it's unlikely that people are going to wear this on a daily basis. And the second issue here is actually the asset itself, right? The virtual asset, creating the virtual human still takes months in order to reach that kind of level. And one of the main issues here is generating a realistic face. That's one of the items that are we're the most sensitive to. And in my previous lab at USC ICT, we've basically been capturing celebrities for high-end production on a monthly basis, right? So the ability to capture all the pore level details, physically plausible skin reflectance properties are all key to be able to generate a realistic avatar. And one of the ways that we were capturing it is using a high-end capture device. So this is Lightstage X, which was developed originally by Dr. Paul de Babic. And these kind of devices are used to produce the assets that are necessary to generate these high fidelity humans. But this is not an automatic process, and there's a lot of post-processing that's happening afterwards. And one of the things that we have been working at Pinscreen is the ability to democratize this digitization process, right? So how can we actually generate convincing lifelike avatars without the need of having people to use such a capture, $1 million capture device? So you can already test our system. We have an app that is available online. And one of the approaches that we have been focusing on is how can we use the minimal amount of information from a person in order to digitize a complete avatar, right? So our approach is basically to have a person take a single picture of its face and upload it onto a cloud, which generates a complete avatar with a custom body that can be attached to it. So what is the challenge here? Well, the challenge here is that from that single input image, there's very limited information. It's just 2D. And one of the most difficult problems is that we need to be able to handle unconstrained images, right? So when you're putting it in a consumer setting, people are not, don't necessarily know what is the best lighting condition. They may take a picture from the internet and the person might be smiling. So you have to basically undo all that in order to generate something that's ideal for avatar digitization. So our approach to that is a recent work that we have published at SIGGRAPH Asia. So you can see this technology. So it's called deep face normalization. So on the left, if we just take a random picture on the internet, the avatar that we produce obviously would have the same facial expressions and all the lightings are baked in. But in an ideal setting, we'd like the person to be captured inside a studio setting where you have well-lit illumination. So you have diffuse lightings around the person. The person is front-facing and is doing a neutral face. So the approach that we took is a machine learning approach based on inverting the entire process of performing the facial expression. So the idea is that we have an unconstrained input image and we have the ability to generate a neutralized face that has a neutral face, it's front facing, and you have well-lit lighting conditions. And this allows us to generate a more coherent avatar, as you can see on the right. So this problem is very difficult to do end-to-end, and our approach consists of breaking this down into multiple sub-problems. The first step of it is basically to have the ability to handle, photos that were captured using different types of lenses and different distances to the subject. So the first step is basically to do perspective on distortion. The second step is basically to neutralize the illumination condition. So in an ideal setting, we have something that is more like a passport picture. In this case, you can see a very, very extreme, lighting setting that is being neutralized using our deep learning approach. One of the hardest steps here is basically to neutralize the facial expression and also to frontalize the person's the person's pose. And one thing you can see here is that the approach that we take to do this is to have many pairs of images where you have the neutral face and you have the face with the corresponding facial expression. And since it's very difficult to capture all these data, our approach consists of augmenting those using a synthesis approach, right? So we generate a lot of data using a technology that I'm going to explain later on. So this whole idea of generating synthetic humans has, people in computer graphics have been working this for a while. And the main issue with the standard computer graphics pipeline is that it consists of generating models and assets that can be rendered afterwards. And these virtual objects are generally created by artists, or there is some computer vision method that is digitizing them from the physical world. But it's always very difficult to generate very realistic looking humans afterwards. So even if you normalize the face, you have the ability to digitize the face, you still have to go through this rendering pipeline. And some of the recent work in generative methods such as generative adversarial networks show that we have the ability to generate photorealistic faces end to end, right? So here's a great example of the evolution of GANS. You can see that every year we have drastic improvements of how neural networks have the ability to synthesize more and more realistic humans. These are examples where faces are being generated from basically random noise, and you have the ability to interpolate them also in a very plausible way, right? And we have been taking this to the next level, which is not just generating static images of people that don't exist, but also have the ability to generate realistic facial expressions. And a lot of that has led to the development of what we know these days as deepfakes, which is an application where realistic faces are being replaced inside of videos of different subjects. So here's a recent deepfake video that we have created in collaboration with John Domenico. So let me play that.
Hello, everyone. It's me, President Trump, the greatest president in the history of presidents. There's some disturbing things on the internet. And I know the internet. No one knows the internet like I know the internet because I'm smart. I'm really, really smart. I know technology and I have a really big brain. And my big brain is telling me there are some fake videos out there. They call them deep fakes. And there's this company, Pinscreen, and they've got like this genius guy running it. He's not as much of a genius as I am, but he's very smart with this technology. So if you see me in a video and I'm not saying how incredibly smart I am and how big my brain is and how I have the greatest memory in the history of memories and how
So you get the idea. So you can see that the problem with deepfakes is that they enable us to generate very realistic faces, and we have the ability to replace people's faces inside any video with whoever we want. So there are new kinds of capabilities that potentially make these this AI synthesis technology very dangerous. And one of the biggest threats that has been discussed a lot in the media nowadays is that not only for spreading disinformation, but deepfakes have been a big issue for non-consensual pornography, right? So people are inserting celebrities inside, porn videos. And those actually, are representing almost 96% of all the deepfake videos that are circulating. So obviously, this is an important step for us to take and to raise awareness, and also to develop technologies to improve the detection of them. So the role of synthetic humans is very important. Here's a recent work that we have done in collaboration with the World Economic Forum, where we're basically showcasing new capabilities of generating realistic faces in real time. So you can see here, one of our engineers is mapping the face of any celebrity onto his face in real time. So you can imagine we could be doing this video conferencing, and I might be someone else. We've been doing further work on this technology, where we're showing how we can generate almost undetectable deepfakes. So here's a...
Boa noite. Dirijo-me a todos os cidadãos brasileiros para dizer que nunca houve injustiça tão grande quanto a prisão do presidente Lula. Que crime esse homem daí cometeu?
Right. So here's a demonstration of a high-resolution deepfake, where we're basically improving the resolution capabilities of traditional deepfakes, as well as the ability to generate a lot more plausible facial expressions. And there are a lot of other apps out there and technologies that are showcasing how not only you can do reenactments, not only you have the ability to synthesize faces and facial expressions, but you have the ability to change certain attributes in a very realistic way. You can change the haircut, you can change or add a haircut, you can change the age of the person. So you have all these high-level controls and more controls over images. So I wouldn't be surprised if we have these kind of new capabilities on videos very soon. And here's another recent work that we have been developing. This was demonstrated at CVPR this year, where we have the ability to author very realistic facial hair on top of images, right? And this is also happening interactively, and we can basically generate different looks of people using this kind of technology. So I was talking about style GANs before, and their ability to generate very realistic appearances of photographs of people. And let me show you how we're taking that into the next level, where in order to generate realistic avatars, we are basically having this approach where we're creating a geometric version of style GAN, right? So on the left, you can basically see this is an input photo. In the middle, this is the way we generated 3D models of the person from that picture. And this is using a standard optimization framework that's based on these squares, and it's basically using the statistical model to fit to the input image. Now, a much more robust and much higher fidelity approach is basically to take that input image and code this into a feature space that is describing the identity, the expressions of the person, and generate this directly into a three-dimensional space. So these are the kind of results that we can obtain these days, and it's something that we're going to be rolling out very soon at Pinscreen. So this leads to how we're going to generate realistic avatars. So if you look at all the technologies that we've seen before, our ability to generate photorealistic facial expressions, our ability to generate high fidelity geometry, we're basically building a technology that allows us to create very realistic 3D avatars that has all the benefits of traditional CG pipelines, which is control. We want to be we want to have the ability for our generated 3D avatars to be integrated inside real-time graphics environments, and this leads to all our efforts at Pinscreen, which is AI-driven virtual humans that can be integrated inside a graphics environment. So our approach is a hybrid approach that combines computer graphics representation as well as deep learning based synthesis methods. And this demo basically showcases how we're, what the benefits are. So on the left, you can basically see a conventional UE4 rendering of a person. So this is a collaboration with Mike Seymour from FX Guide. And on the right, you can actually see how we're combining the CG content with our ability to infer photorealistic faces using our pagan technology. So let me play this and show you how this looks like.
Hi, this is Digital Mick, kind of the successor to Meet Mike. This is me driving this digital character in UE4 thanks to a persona rig from 3Lateral that's reading my expressions, feeding into a 3Lateral facial rig inside UE4. I also have on an XN suit to get my body motion. And this is great, we love it. But as much fun as I am sitting here at the Modus Lab in Sydney, I can take this to the next level thanks to our friends at Pinscreen. This is Digital Michael. Now, Michael is being fully driven by Digital Mick. So just to be clear about this, Mike Seymour is driving Digital Mick and Mick is driving Michael. And Michael lifts the level of realism enormously. It's doing that because it's a generative adversarial network, a GAN. In fact, it's the Pagan 2 technology from Pinscreen. And this is enabling me to produce this incredibly realistic, lifelike version of me and control it. I think it's extraordinary technology and it's really going to be a game changer. I hope you agree.
All right, so this gives you an idea of what the possibilities are once we have the ability to cross the uncanny valley using this very advanced version of real-time synthesis on top of a standard computer graphics engine. And this is not just a post-process where you're just replacing a CG face with a photorealistic one. One of the key aspects of it is that you still have the ability to have natural light interactions inside the virtual environment, as well as the ability to handle occlusions and everything. So it has to be implemented tightly inside the engine. So let me show you a couple of examples on what we can do with this. So here is, obviously we have the ability to generate very convincing virtual avatars now. The faces look very real, and we can, simulate any pose, any, shape of the avatar and digitize high fidelity avatars much faster than the traditional approach of going through a graphics pipeline. And here are a couple of examples of work that we've done with our clients. We have the ability to digitize, celebrities, and for many applications such as for clothing brands, etc. And they don't have to be static, right? We can integrate them naturally inside a real-time game engine and simulate realistic movements. So the main goal actually of Pinscreen is not just to have a solution for digitizing realistic avatars. We're also trying to bring intelligence into the avatars, and we're really building a next generation virtual assistant technology where people can interact with a completely synthetic human, right? The ability to build virtual avatars for e-commerce, as well as having a virtual companion, as we know from many science fiction movies. So, we basically, I'm not going too much into details here, but we do have a full stack solution for AI and NLP. So our solution consists of a web browser where people can chat in real time with the avatar. We can type, you can talk to the avatar. We have a system for voice recognition, realistic and convincing chat responses. It's completely freestyle conversations. And one of the key aspects here is not just to provide a realistic response, but also a realistic behavior. So we have the ability to generate, from the voice, realistic lip animations, gestures, and even nonverbal facial expressions, and stream this in real time using our pagan technology and standard video streaming technologies to the users. So our entire system is actually cloud-based, and you have basically a virtual assistant. So I'm not going to demonstrate the avatar here, but I'll invite you to actually check out our live demo at SIGGRAPH Real-Time Live. And we're also going to post videos of our Pinscreen virtual assistant. And also feel free to contact me if you want to have a live demo of our real-time virtual assistant technology. So we've talked a lot about how to create realistic parametric versions of virtual avatars. So that includes digitizing them from an input image and integrating them inside a game engine as we know today. But there's also a lot of thought on what if we wanted to have a direct way of capturing the entire person, similar to how we do 3D scanning, but have the ability to capture this representation, the point cloud of a person, and directly stream that to the viewers. And that's something that's very relevant when we talk about next generation communication technologies like 5G, right? Here's a work from Microsoft Research, where from a couple of years ago, where they basically have they're showing a concept video where you have a person that is interacting with another person who is completely remote and has the ability to capture the entire performance of the person, stream that directly to the other person, and they can see each other in 3D using this augmented reality headset, right? The obvious problem here is that you do need a very sophisticated capture setting, so multiple depth sensors around the person in order to capture his or her performance. Here's a similar demo, more recent one from Evercoast, where they're using a rig that consists of multiple Intel RealSense cameras that are capturing a point cloud of the person and streaming this online in real time. And one of the obvious things that you can do here is that you can remove the background, insert that person inside another virtual environment, or allowing another person to view that person. So this is really what we mean with the next generation for virtual connectivity and using a volumetric capture setting. So the main issue here is that you do need a lot of cameras, and it's unlikely that people are going to have these kind of capture systems at home. And what is more realistic is that now the thing that's really practical about our system nowadays is that we just have our laptop, and we have a single webcam that's looking toward us, and that's something that is more deployable. So we started to think about this problem a couple of years ago, and the question was, is it possible to still obtain a complete digitization of a person even though we only have a single view? And what it means is that we need a model that is capable of inferring a plausible back of my body as well as a 3D representation. And most likely we're going to be wearing things, we might have props or accessories, and all those have to be digitized in 3D as well. So here's a recent work that we've done. It's called PIFU. PIFU stands for Pixel Aligned Implicit Functions, which is a new representation and learning approach that allows us to generate a complete 3D model from a single picture. So this is how it works. This is a picture of me in Sydney with my friend Mike Seymour. And the first step is basically to do a semantic segmentation and remove me from the background. So that's a solved problem that can be done using a standard neural network. And once we have obtained the segmentation, we can infer the entire 3D shape of myself. I'm going to explain how that works. The idea here is basically that from this input image, we basically map this into a 3D mesh that is textured. So you can see that it can not only generate a plausible geometry of my body, but also infer the texture on the back of my body as well. And the standard approach is you have an input image is encoding into some latent vector and it's trying to decode it and generate the content. Now, the main problem there is that those kind of approaches are not very effective, and they usually generate a lower resolution and more degraded version of the 3D shape. So our solution to this is, as I mentioned before, is called Pixel Aligned Implicit Function, right? There are two important steps here. The first one is how do we have an effective representation that has the ability to still get a highly detailed shape of the person, that has the ability to learn this properly. The standard approach is to use a occupancy field. Basically, you have a voxel discretization of space, and you have this uniform grid. It's suitable for convolutions, and it basically tells you where there is something or if there's nothing at that specific location. The only problem with the voxel representation is that it requires a lot of memory, and for these kind of learning approaches, being bounded by this resolution is a big problem in order for you to generate high fidelity content. So our approach to this is to actually use a sort of like a level set approach based on implicit surfaces, which allows us to determine freely at which position in space we want to determine if there is a point or not. So instead of a voxel representation, we're using an implicit surface representation. The second thing is, standard approaches for 3D deep learning take an input image, encode them into a global feature vector, and then generate the shape from that vector. The only problem is that there's a lack of spatial alignment between the input image and the generated content. So in order to fix this, we came up with the approach of using a pixel-aligned representation using fully convolutional neural networks that allows us to have a better correlation, spatial correlation between what has to be generated afterwards and the input image, right? So we're, instead of having one global feature vector, we're using multiple ones at each XY pixel position. And in this way, we can basically ensure high fidelity output. So let me show you a couple of examples. Here are some really interesting results where we have only a single input image of a subject, and you can see that it gets the bending of the knees right, so you can generate a plausible result out of it. And one thing that's also interesting that you can see on the picture on the upper left is that even with props, it can generate a plausible reconstruction. So it doesn't have to be only a single human body, right? Here are a couple of additional examples. So one of the problems here is that if you apply this technology frame by frame, then you usually have an issue where the digitized output. So if your input is a video instead of a static image, then what happens is that you might get some temporal inconsistencies between the frames. So what it interprets as, this is a plausible pose might give you some temporal flickering when you're generating the results. And another problem is that it's just a static mesh, right? So you don't really have the ability to animate it afterwards. So one of our recent collaboration with Facebook Reality Labs is, instead of inferring the 3D shape of the person in the pose that is in the input image, we basically try to generate the textured mesh of the avatar in a canonical pose, right? The canonical pose in this case is an A pose, which is suitable for building a animation rig from that model. So the idea here is to to implicitly use the prior of a naked body model as prior in order to directly infer what the pose would be in a neutral pose. And in this way, we have the ability to generate arbitrary animations and also at the same time enforce the shape to be more natural. So let me show you an example. So on the upper left, we have an input image. So you can see this is a very challenging pose of the person. The hand is, basically touching the waist. You have an entire arm that is actually touching the body. And from this, we infer the A pose, so it knows what a body pose, what body shapes are from the person, and it reconstructs the person in both simultaneously in the neutral pose as well as in the input pictures pose. And what we can generate is an animated avatar from that input image, right? And we can arbitrarily animate it since we get this animation rig. The other benefit of using this approach is that we can also obtain temporally coherent output when we have a stream of a video. So on the right, you can see on the third video, you can basically see our original PIFU implementation, which is what we expect, right? So when we process them frame by frame, we have these temporal inconsistencies. But in the second video, you can basically see if we add this human body prior into the digitization, we get this more plausible reconstruction. So it prevents us from having these temporal inconsistencies. Now, the resolution is still limited, especially if you have high resolution input videos. This is recent work from my student Shunsuke Saito in collaboration with Facebook Reality Labs, where he's basically showing how we can generate high fidelity reconstructions if you have high resolution input videos, right? And the idea here is really to use a coarse-to-fine approach during the inference of the model, so it has the ability to capture more of the geometric details and also improve on the temporal consistencies across frames. Now, the last thing that is needed here is how do we digitize these models in real time, right? So all these examples, they take multiple seconds or sometimes even a minute to generate a single frame. And one of our recent work that we have published at at ECCV this year, and also as a demonstration at SIGGRAPH Real Time Live, is basically the end-to-end solution for a prototype volumetric teleportation system. The idea that only uses a single input camera. So you can see here, the only input that we have is a webcam, and we can in real time generate complete avatars, including the clothing, including a mesh and a textured mesh that you can see on the right. So this is being all generated in real time. Here's another example where we have a 360 rotation. So you can see that even though the camera is front facing, you can infer the back of the person. So let me play that again. And here's another example where we're streaming the subject's performance directly into an iPad tablet device, So you can see the subject that is doing its funny dance, and the avatar is being digitized in real time and streamed directly onto this augmented reality application where we have the ability to move around the avatar, see it from different views. And this is sort of like a first building block to what we think could lead to a technology that we have seen very often in science fiction movies such as Blade Runner 2049, So the ability to have this holographic display of a realistic looking virtual human that people can interact with, or it could be just another person where we're talking to remotely. So to conclude, this is a set of, I presented a couple of technologies that showcases how we can use virtual avatars as well as technologies like volumetric teleportation in order to build, a framework where in the future we have the ability to, connect and interact more effectively in a completely virtual setting. And yes, so if you'd like to learn more, please visit our website at pinscreen.com. We're going to showcase a lot of new products and technologies where we're basically enabling this future. So I would like to thank you all for your attention, and ping me if you have any questions. Thank you very much.